Yo, what up everybody? We got 10.2 and 10.3 up in here. Arcs and Chords in Circles by Mr. West. Y'all better watch the whole video and take some notes while you're at it. Alright? Go and learn something. Alright, now check this one out. Alright. Teaching you about arcs and chords, angles and measures. To make videos is my pleasure. Help you understand the geometric concept. Watch this video and gain that knowledge. One last time, you have to understand. Homework every day to get the upper hand. Yeah. Check it out. Hey, what's up everybody? Let's find arc measures. Okay, what's an arc? Okay, let's talk about that. Well, let's start off with saying we have some type of angle inside a circle. This would be called the central angle. Okay. Now, let's say we have an arc. When we have a central angle, okay, this arc is formed between A and B. Do you see this arc? Oh, it's not a straight line, it's called an arc. And that's going to be called a smaller arc because it's less than 180 degrees. So it is A to B is going to be called the minor arc. Okay, there's another arc formed between A and B, and that's going to go all the way around the other way. That's another arc. It has a different name. It's called the major arc, the one that's bigger than 180 degrees. Now there's different ways that we're going to write these major and minor arcs. So a minor arc is between A and B, right? So that's going to be, let's say we want the measure of A, B. But an arc doesn't have a line, it has an arc on the top of it to represent AB. But a major arc, you notice like, yeah, it's between A and B also, but going the other way. So we need to have this other point D there. So that's going to equal, let's say we have the measure of AD, B. And then we have to have an arc over it, just because to represent the fact that it's an arc around a circle. Alright, let's say that we have just one point. Let's call it point W. Okay, there's only one point, so we go all the way around the circle for this arc. This arc is just a circle, okay, so we want to find the measure of arc W. There's an arc. Well, it equals 360 degrees. Another type of arc. All right, let's say we have a point here. Let's use a different color. Let's say we have a point here. This is P, and the point here is Q. Well, if we're going to have one side of the arc going this way, that's halfway around, okay? Because this is actually the diameter. So that's called a semicircle. Or half a circle. And there's also a semicircle on the other side, all the way around the other way. This going this way is also another semicircle. A semicircle is going to equal, let's say the measure of PQ, arc over it, equals 180 degrees. Alright, let's have a little example here. Let's say that we have this point E, and we have this point W, and this point S. E to W is 100 degrees, W to S is 100 degrees. What is E to S? Okay, we can draw like a central angles here. So E to S, so I know, let's say I find E, S, I have to have an arc over it. We're talking about the measure of it equals, well, it's kind of, well, the whole thing is 360 degrees. So let's do the math down here. 360 minus 100 equals what? 160 degrees. So the measure is 160 degrees between here and here. And is that a minor arc or a major arc? I would say that ES is a minor arc. That's about finding arcs measures in these circles. Okay, here's an angle. And what about arc addition postulate? Well, let's just remember something else. You remember the addition postulate, segment addition postulate? This was like really easy. That meant like CB plus BA equaled CA. Well, the same thing with with this one. It's the same idea. Let's say we have WE, EW. So we're going to have the measure of WE, and now there's an arc over it, plus the measure of ES, and it's an arc, is going to equal what? Obviously the measure of W to S. And there you go. Let's define congruent circles and congruent arcs. Well, if a congruent circle, if two circles are congruent, then they're going to have the same radius, right? Because that defines a circle. So R and R would equal R. Okay, if we had the same radius, we would have congruent circles. We have congruency. What about congruent arcs? Well, they need to be the same circle, so R must equal R. And they also need to have the same arc measure. The arc measure, don't forget, is between here to here. It would be the central angle. They also need to have the same one. So if we have the congruent arc, they need to have the same angle, and the radius must be the same. So let's look down at these examples over here. Which ones tell whether the red arcs are congruent or not? So we don't have to explain, we can talk here. Here's the red arc and here's the red arc. Are they congruent? Well, they're in the same circle and they both have 80 degrees. I would say yes. Let's see if you can find B and C before I can. Alright, this one, well, we have the same arc measure. They're both 90 degrees for this red one and this red one. But the thing is that they have different radiuses. Okay, so I would say no for that one. No way, they are not congruent. Okay, and this one. Alright, C. Well, we both have 95 degrees. Oh, and look, the radiuses are the same. They have the same radius right here and here. So I would say yes, the arcs are congruent. Alright, let's talk about properties of chords. Some stuff maybe we already know. Let's say we got this chord right here. We also know it's because it goes to the center, it is a diameter. Well, what type of arcs does it create? It creates this arc, and it creates this arc. And what are those called? Those are called semicircles. So we know if a chord is a diameter, it creates two semicircles. What if we have a different type of arc? What if we had this, not an arc, a chord. This chord, this chord, that is not going to the diameter. It creates two arcs. It creates this arc, and it's going to create this arc. Right? And the green arc is going to be called the major arc. We already know that. And the little orange arc created by this chord is called a minor arc, which we should already know. Okay, so what if we in the same circle or in congruent circles? In this case, we're going to just deal with the same circle, which is two congruent circles, whatever you want to think about it. Two minor arcs are congruent. So we have two minor arcs. If and only if their corresponding chords are congruent. All right, what does that really mean? Well, let's say we have this center point and we create this arc and this arc and that arc. That means that this arc and this arc are the same, okay, because let's say this is x degrees and this is also x degrees. So that means that measure of AB is congruent to the measure of BC. That's an arc. Okay, that means that from here to here must also be congruent. So if the arcs are congruent, then the chords are congruent as well. All right, let's come back a little bit. Let's erase this. Let's think about something else. Okay, now let's say that we have from B to A is a length, and from B to C is also length. If this is 9, and I say the measure of AB is congruent to the measure of BC, that's an arc. Okay, then if this is 9, then this is also 9. Okay, and I know that angle A to C, or this arc, let's talk about this arc here, is 150 degrees. Really, if we knew that AB equaled BC, then I need to find out two distances that would be the same that are going to finish up to 360 degrees. So I would have 360 degrees, 210 degrees, not AC 160 degrees is what I made a mistake doing. It's not 80 degrees. It's 105 degrees. But I'm not going to redo the whole video. But we know that AB and BC 105 degrees, not 80 degrees. So we could even erase this one and say that because we know that AB equals BC, that's the same thing as 2AB, right? Alright, so what does AB equal? Well, we know that AC is 150. So we have 150 plus 2AB. What's 360 minus 150 is Alright, let's read a theorem here. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So, if we have a chord here, from here down to here, and we have another chord from here down to here, we know that they're perpendicular bisectors, so this is congruent to that. Then, we know that it is a diameter. This one is a diameter 100%. Alright, this second property down here, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we're saying if this right here is a diameter, alright, and then this chord here is also, it goes to the center, let's go center up there. Then we know if this is perpendicular, therefore we know that this segment here is congruent to this segment there. How does that help us out? Well, if we said, I want to find out here, find a fourth point, the same distance from all 3 points. So we have a point A, a point B, and a point C. Okay, I want to find a fourth point, whether it's here, here, here. I want it to be the same distance between A, B, and C. Well, let's pretend that we have a circle going on here. Going through all of these. Okay, we can use the properties that we just learned. Let's find chords between these two. There's one chord, there's another chord. Alright, if I can find a perpendicular bisector, where this is the same and this is the same, and another perpendicular bisector where this is the same and this is the same, the perpendicular, perpendicular, bisect, bisect. Therefore, this guy is going to be the center because these guys would be diameters. If it's the center, then we have radiuses from here, here, and here will all be congruent. And there is our point W that is equidistant to A, B, and C using these theorems. Okay, let's check out this theorem. Let's say that in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so what does that really mean? Well, if this chord and this chord, okay, now I'm saying if they are congruent, if, then between the center and a point perpendicular, and from here to a point perpendicular, those things are also going to be congruent. Okay, that's all it's saying. So let's say that I show you this example, and I say, well, actually, QR is congruent, or line segments, is congruent to ST. And you're like, oh, QR is congruent to ST? Sweet. So that means between this point and this point, and this point and this point, are congruent. That means that 2x actually equals 4 and x equals 2. It's as simple as that. There you go, some properties of circles and chords and tangents. See you later. Peace.